Assalamualaikum and good day everybody. So our topic today is factors affecting the rate of genetic change. In the previous lecture, you learned factors that you could do to change the genetic allele frequency or genotype frequency, so that you can change the genetic, you can change the gene towards the trait that you want to improve your desired performance that you want. And but then you have to check rate of genetic change, so that you know how fast you can change the genetic. So this will determine the successful of the genetic improvement program. So by determining the rate of genetic change, we can actually measure the effectiveness of selection during the breeding program, and we can check whether we can achieve the objective of selection. So if we could revise back, our objective is to maximize the rate of genetic change, and we want to also choose those animals with the best breeding value to be parents in our breeding program. In order for us to determine rate of genetic change resulted from selection that we did, so there are few factors that you need to know, and all those factors is appear in what we call the key equation. So this is the formula for you to calculate rate of genetic change. So in this formula, in key equation, so there is in order for you to get rate of genetic change, so this will be counted in unit of time. So you need to get information on the accuracy of selection. You need to know the selection intensity, genetic variation, and also you have to divide all those to generation interval. In the key equation formula, what we want to know is actually the rate of genetic change. So this is actually the response to the selection that we did in the genetic improvement program. So rate of genetic, we translate it in the mean breeding value of a population caused by selection, and we divide that with the t, which is we measure the generation interval. Therefore depends on type of species. Some species that have short generation interval, and other species have longer generation interval. So generation interval refers to the time where we replace that individual with the next generation. The key equation is based on four factors, which is accuracy of selection, selection intensity, genetic variation, and generation interval. So we will go in detail for each of these in the next slide. The first one is accuracy of selection. So this is actually the strength of relationship between true breeding value and their prediction for a trait under selection, the trait that we want to improve. So the prediction is actually the short form is EBV, expected breeding value, is used for selection, which is what we call selection criterion or the short form is SC. So this is actually how accurate we can predict in terms of selecting individual that we use in the breeding program. So accuracy should be based on the data or history of that particular individual. Okay, for instance, their weight, their height. So all those information should be used um, to predict accurately predict the breeding value. So accuracy could be ranged from zero. So zero refers to no information available at all for that particular individual, to one. So one refers to lots of information, many data available to be used, to be manipulated, that we know from that individual. The second factor is selection intensity. So this refers to how intense or how choosy is the breeder in deciding which individual that they select. So they really choose uh, the pool that they have in the farm, or they really carefully choose individual that they use in the breeding program. So this is refers to the selection intensity, how intense of the selection carried out during the genetic improvement program. The third factor in the key equation is genetic variation. So genetic variation is the variation of the genetic information exists in one location in alleles that is available to be used in the breeding program. So this is fairly fixed in a population, but then in the case of outbreeding, it will increase genetic variation, and we know that inbreeding will reduce genetic variation among individual in the population. So genetic variation, the change um, is slow due to either long generation interval, lack of accuracy, intensity or consistency of selection, or all of the above. So this will slowing down um, the change in terms of genetic variation. And the last factor in the key equation is generation interval. So this is the amount of time required to replace one generation with the next. So in the closed population, it means the average age of parent when their selected offspring are born. As I mentioned before, um, generation interval, long generation interval will slowing down genetic variation, and it will affect it will slow down rate of genetic change as well in the key equation. In the key equation, we can replace accuracy of selection if we have information on the phenotypic selection. So we can replace accuracy of selection with heredity if we have information on the heredity, and we can replace breeding value variance um, by measure of phenotypic variation. So this is another formula to calculate rate of genetic change. So you replace those two items, which is heredity and phenotypic variation. Either formula can be used.